video, we're going to model the same data set that we used in the Minitab video. Um, it's about 50 gems in an auction, uh, and the details related to this auction is given in 5 variables. Price is the sold price of the gem at the auction, and age is the years found of that gem, and size, attendance, respectively have the same meanings, and gender is an indicator variable with the male as the reference level. So now we need to model this data. So we use regression modeling. So before fitting a regression model, so we have to do few steps as I mentioned. So we need to draw scatter plots. So there we can go to scatter, and here first you have to select the data range. So go to design and select data. So I don't need this array, or you can remove this array, and here I need to draw this price variable, and along with age. So what did I do is first select the chart option, and then I selected the scatter plot, and I selected the Y range first. After that, I in this window I choose the edit option. There I had to fill this X values range, so I fill the value of B without the name. So when you are choosing Y, you can select the name or select the range including the name, but when you are selecting the X range, select the range without the name, then press OK. So you can do this thing, add another name. Suppose it is price versus here we can select the name price, and the Y values range is this. X values range is size. Now you can ask these two plots to be in same plot. So now you can see both the X variables are drawn in the same plot. Here price is the Y variable, and age and size are differently demonstrated in two different colors. But they are included in the same graph. So I'm not recommending this graph for the analysis part, but you can take this graph separately as we did in the Minitab video. So you can take price age, price size, price attendance, and age size, age attendance, and size attendance in separate scatter plots, and you can see clearly the distributions of those variables in pairs. So but here I need you to show how to draw a scatter plot. So first then we need to get the correlation matrix after inspecting the patterns of these scatter plots. So there I need to use data analysis add-in. If you haven't add this to your data tab, you have to add this first. Then you have to select correlation under this. Select the range. So input range is this. So we calculate the correlation for quantitative variables. So my columns have separate variables. So I select columns here, and first row of this data set contains the names of the variables. So therefore I have to tick this box, and I need the output of these to be displayed in the same worksheet. So I select a cell and press OK. Then I can see the correlation matrix. So price is our response variable, age, size, and attendance are predictor variables, and you can see age and size are highly correlated with price, while attendance have a weak correlation with price. Both all correlations are positive, and here you can see the correlation between size and age is high, which means as this strong correlation suggests us there could be effect of multicollinearity. So in this video, we are hoping to find VIF values using Excel to get the multicollinearity. About the idea about a multicollinearity effect. So after recognizing this, we can say price can be modeled with age, size, and attendance. So I am using these three only to model the first model. Now we can start the model with only the quantitative variable. So in the first place, we are not considering, we don't consider the gender variable. To model this data set, we have to go to regression in the data analysis option. So in this dialog box, price is our response variable. So we have to select the price range first. Then we have three predictor variables. So I select the range at once, and I need labels. So if I want to model this data set without the intercept or beta naught, then I can select this, but I don't need that. And if I want to run this regression calculation under a significant level different than 5%, you can take this and edit this box. And I need my output to be shown in another worksheet. So I select this, and I need residual plots and normal probability plots, and press OK. So here you can see the normal probability plot. Residuals are can be, or we can conclude that residuals are following a normal distribution. And here with these diagnostic plots, we can say these are distributed in a band. So constant variance assumption is okay, and residuals following normal distribution, and we can say the model diagnostics is okay. Then we go to the ANOVA table and interpret the significance value or p value of the ANOVA test. So here we have three variables, which means we have beta 1, beta 2, and beta 3 parameters. So this ANOVA table checks the null hypothesis, that is beta 1 equal to beta 2 equal to beta 3 equal to 0. So since this value is less than 0.05, but the model is significant, which means not all beta 1 or beta 1 or beta 2 or beta 3 are equal to 0. Then we can interpret the model So we go to these are the beta hat values. So estimated values for these betas. So this is beta naught hat, beta 1 hat, beta 2 hat, and beta 3 hat. Then we can refer this p-value column to get an idea about the individual significance of these betas. So here these three p-values are less than 0.05, which means beta naught, beta 1 and beta 2 are significant, but attendance have a p-value greater than 0.05, which means attendance is an insignificant factor for price prediction. So beta 3 is equal to 0. So we don't have enough evidence to reject the null hypothesis beta 3 is equal to 0. So those information can be found in this formula. Then we can go to this table and see the R square adjusted value. So it is 91.2%, which means it says about 91% of variation in price can be described using age, size, and attendance. So that is how you can model a multiple linear regression using only quantitative variables. Now we move to this data sheet, and suppose I need to calculate the new variable, but which means I need to add the interaction term of age and size. Before that, we need to find the multicollinearity effect of size, age, and attendance. So to do so, we have to calculate, or we have VIF value. To calculate the VIF value, we have to model age or model each uh, predictor against the other predictors, which means here first I model age versus size and attendance. So I take age as the response and size and attendance as the uh, predictors, and I feed the model. So using the fitted model, I calculate the VIF value is 1 over 1 minus r square of this model. So here r square is this. So you can see the VIF value, the variance inflation factor related to age is 6.3, which means it is greater than 5. So the multicollinearity is in this model. Multicollinearity effect is in this model due to age. So in the same way, I can find the VIF value related to the size. So I need to uh, select size as the predictor, the response, and age, and to separate the data you have to use semicolon, and attendance as the predictors. So here you got an error because of this colon operator. So I advise you to rearrange the data set and model these. So in this case, you have to we have found age versus size attendance. Now you have to get the model of size versus age and attendance and calculate the VIF value using 1 over 1 minus r square, and again consider attendance as the response and age and size as the predictors, and build the model attendance versus age and size and calculate the VIF value using the r square of that model, which means 1 over 1 minus r square. So then if the VIF value is greater than 5, we say there is a high multicollinearity effect in this model due to those uh, variables. Now, after seeing that is how you can see the multicollinearity effect in the model uh, using these uh, multiple predictors. So now I need to consider the interaction effect of age and size. And at the same time, I need to consider the gender to the model. So first, I multiply age with size and I create a new column, age times size column. So this column helps us to find the interaction of age and size to the model, and gender is also in the terms of interaction, not the indicator variable, and this is interaction and this is the indicator variable, where one is the reference levels, one denotes for males and zero denotes for females. So just if you have a qualitative variable in your data set, you have to convert those qualitative variables into interaction variables and type or input those indicator variables to the data sheet as we have done. So here we have only two levels in the gender variable. So uh, 2 minus 1 equal to 1, which means one indicator variable is enough to represent gender variable in our model. So we go to the data analysis and select regression. Now again I have to give the actual response variable. It is price, and our range is now age, size, attendance, gender, and age, size, interaction column. So we have 5 columns. So we select those things, and I need labels. I need this output to be in the separate column. So I need residual plots and normal probability plots. So in a separate worksheet, I can see these diagnostic plots and the normal normal probability plot and the residual plots. So you can see these uh, residual plots are okay with the assumptions that we make. So we can go to the model interpretation. The significance value is less than 0.05, which means the model is significant. Then we can go to the coefficients. So these are beta hats, and these are the significant individual significant test of these beta. You can see beta naught is insignificant. This value is greater than 0.05. And these three, which means beta 3, beta 4, and beta 5 are insignificant. Only the age and size are significant. So if you don't want these terms into the model, so you can remove those variables, and or you can drop those variables and consider only the significant variables in the model, and you can improve the model by remodeling with less variables. But if you need all the main effects to be in the regression model, so you can eliminate only the interaction term. So and model do the modeling again without this interaction column. So if the interaction is significant, then we can consider main effects inside the model, though they are insignificant. But here the interaction is insignificant, which means we can drop the interaction term directly. And then we can go to R square adjusted. So it is about 90% of variation in price can be represented or described using age, size, attendance, gender, and age, size, interaction terms. Now suppose we need to get the prediction band of a new observation. To get that, we have to create a column called prediction, and we have to fill that column with zeros, and you have to give the new observation to the last line. So there we don't know the price value, so we put it as 0, and we can say 150 new observation has age of 150 and size of 100, and attendance is 8, and the gender is 1, and we don't need this column now. So for the prediction column of the new observation row, we put this minus 1. Since we don't need this anymore, I delete that column. So now we have only the main effects, or we have only the variables with the new prediction column. Again, you have to, so here, see, these are the values of the new observation, and for the prediction column you have zeros, and only for the new observation row you have -1, and in the response variable column you put a 0 to the new observation and model this data. So go to build a regression model again, and here now we have 52 cells, and here the range is selected again like this. Now I don't need this, and press OK. So in a new worksheet I can see this, and this is the new or fitted value of the new observation, and this is the prediction interval of the new observation. So that is how you can get the prediction interval of a new observation using this Excel. Now we can find the confidence interval for the mean response of a new observation. For that I need to calculate age, size, attendance, and gender again by subtracting the values from the new observation. Here I have to subtract the entire age column from the new observation value corresponding to the age. So it is 150. Here I have to subtract the entire size column from the new observation value. It is 100. And for attendance again I am subtracting the entire column with the new observation 8. And for gender I am subtracting the previous column with the new value. Then I have to create these 4: age, size, attendance, and gender column. So I completed these new columns by subtracting each respective column from their respective number here. Now I don't need this row because I need the confidence interval for new observation, mean response of the new observation. So again I'm modeling this Y. So here we have only 51 cells now, and the range of input X or the predictor variables is changed now. So we have to select the newly calculated variables by subtracting each value of the new observation by the corresponding column or the variable in the data set. So I selected age, size, attendance, and gen newly calculated variables by subtracting each corresponding value from its previous original value. Then I put OK. So in this output, this is the fitted value. So you can compare this one. So this is, let's copy this one and go back to the previous sheet. So here, this was the fitted value and this is fitted value. So both values are equal. So which means now we take the confidence interval for the mean response of the new observation. So it is this. So let's copy this and paste it here. So you can see this is the prediction interval and this is the confidence interval for the mean response, and this is the fitted value. So let's say this, copy this one and paste it here. You can see this prediction interval is wider than the confidence interval of the mean response of the uh, new observation, and this is the fitted value. By substituting those new observation values in the fitted line uh, of this example, so this is how we can uh, get the 95% prediction interval and the 95% confidence interval for the mean response of the new observation. So this is the last step. So we can see all the necessary outputs for a regression analysis in this video. So you can go through it and you can solve any type of regression analysis question using Excel by going through this video.